Section 12.2 here is matrix multiplication. I can multiply matrices using scalar and matrix multiplication. Big ideas. To multiply a matrix by a scalar, multiply each element in the matrix by the scalar. If A is an m by n matrix and B is an n by p matrix, then A times B is an m by p matrix. A real number factor is called a scalar. Multiplication of a matrix A by a scalar C is scalar multiplication. To find the resulting matrix C times matrix A, we multiply each element of A by C. And the take note on page 772 talks about that. So to multiply a matrix by scalar C, multiply each element of the matrix by C. So we take this C and we multiply it by every element. It's like we distribute it all the way through. Example 1, using scalar products. If this is our A matrix and our B matrix, what is 4 times matrix A and 3 times matrix B? So I'm going to take 4A, which means I need to multiply every element by 4. And I'm going to take 3 times matrix B and multiply every element by 3. 4A is going to be 8, 32, negative 12, negative 4, 20, and 8. B is going to be negative 3, 0, 15, 0, 9, negative 6. All I did there was simplify all of my products. Just multiplied those and rewrote it. Now, I have to add my two matrices. In order to do that, I add my corresponding elements, which means 8 plus negative 3, 32 plus 0, negative 12 plus 15, negative 4 plus 0, 20 plus 9, and 8 plus negative 6. Now I can simplify these. 4 times matrix A plus 3 times matrix B is going to be 5, 32, 3, negative 4, 29, 2. Now, using matrices A and B, what is 3 times matrix A minus 2 times matrix B? Again, I'm going to take 3 times matrix A, which means I multiply every element by 3. I need to take 2 times matrix B. I'm going to multiply every element by 2. I'm just going to rewrite these. 3A is going to be 6, 24, negative 9, negative 3, 15, 6. And 2B is going to be negative 2, 0, 10, 0, 6, negative 4. I need to subtract these. So 3 times matrix A minus 2 times matrix B. I take corresponding elements and subtract. 6 minus negative 2, 24 minus 0, negative 9 minus 10, negative 3 minus 0, 15 minus 6, and 6 minus negative 4. Last step is just to simplify my differences here. 8, 24, negative 19, negative 3, 9, 10. And this is 3 times matrix A minus 2 times matrix B. Take note, on page 773 deals with scalar multiplication and our properties. Again, our closure property, our associative property, multiplication, distributive properties, multiplication identity, and multiplication properties of 0 are all there. So you can look at those. Those are properties that are very similar to the ones that we've been dealing with for as long as you can remember. Example 2, solving matrix equations with scalars. So what is the solution of 2? Capital X means this is going to be a matrix. We're looking for a matrix. So 2 times some matrix X plus 3 times a matrix equals a matrix. So first thing we're going to do is distribute. Take our scalar in. So 3 times 2, 3 times negative 1, 3 times 3, 4 times 3. And I'm just going to rewrite this matrix. I'm going to have 6, negative 3, 9, 12. Just distributed in the scalar 3 to each element. Now, I need to subtract this matrix to move it to the other side. Again, we're still trying to solve for x, so we have to get it by itself. So minus 6, negative 3, 9, 12. Subtracting matrices here. So in order to do that, I take 8 minus 6, 5 minus negative 3, 11 minus 9, and 0 minus 12. I'm going to go ahead and simplify that. 2, 8, 2, negative 12. Now, I'm going to divide by 2, but another way of writing division by 2 is multiplying by 1/2. And that's ultimately what I'm going to want to end up doing here, because I need to know that my scalar is 1/2. That's what I'm going to multiply by every piece. So I'm going to take every element inside my matrix and multiply by that 1/2. It's just like dividing by 2, guys, but with scalars we use multiplication. And I talked about this briefly when we were solving equations with matrices, that we were going to want to use fractions instead of division. Half of 2 is 1, half of 8 is 4, half of 2 is 1, half of negative 12 is negative 6. And this matrix right here is our solution. It's our X matrix that satisfies this equation. Now, same idea here. What is the solution? When we do this, guys, 2 options. We can either take a negative 2 to each piece and then subtract, or we can take just the 2 here, which is what I'm going to do, and then add. Okay, I'm going to multiply by 2, multiply by 2, multiply by 2, multiply by 2. So I have 3 times matrix X minus negative 2, 10, 14, 0. And the reason that I did that, guys, I know usually we take the sign with the number, and you definitely can, but now I'm just going to add this matrix. it really does not matter in the slightest. I just prefer to add matrices and subtract. Again, it does not matter at all which one you chose there. Again, additive inverses still add to 0. Now, I take 17 plus negative 2. I take negative 13 plus 10. I take negative 7 plus 14. And I take 0 plus 0. Simplify this. 3 times matrix X is going to be 15, negative 3, 7, and 0. Now, 3 times a half is 1. So all I have left is matrix X equals a third of 15 is 5, a third of negative 3 is negative 1. Here I have 7 thirds, and that's fine. I know some of you see fractions are like, wait a second, that can't be right. That's what we should get here. It's okay. So, our matrix X is this right here. The product of two matrices is a matrix. To find an element in the product matrix, we multiply the elements of a row from the first matrix by the corresponding elements of a column from the second matrix. Then we add the products. So take note on page 774. To find the elements again of our matrix, we multiply each element in the ith row of A by the corresponding elements in the jth column of B. Then add the products. Guys, this is a little bit like foiling in that we have to do the entire thing. So we can't just multiply the first and the last. In foiling, we have to do the outsides and the insides. Same idea here. We have to do the entire column. So this spot right here is like x sub 1, 1. Here we have x sub 1, 2. Here we have x sub 2, 1. This is x sub 2, 2. So the first number is our row and then column. And we need to include the entire piece of that. So we're going to take the entire first row times the full first column here. Okay? A1 times A sub 1, 1 times B sub 1, 1 plus A1, 2 times B1, 2. Or 2, 1. Sorry, we have to do those first row times the whole first column. To get to this spot right here, I need the entire first row times the entire second column. So, I take the first row times the second column. Then I take the second number in the first row times the second column. Same idea down here. This is the second row, first column. So I have to take everything in those rows. First thing in the first row times the first thing in the first thing in second row times first column. Second thing in the second row times second thing in the first column. And my final spot is second row, second column. So I take second row times second column, and then the last thing in the second row times the last thing in the second column. And that gets me to here. So it's a little bit like foiling again, guys. We have to take the entire row times the entire column, entire row times the entire column, entire row times the entire column, entire row times the entire column. Then we add up everything from that row column combo. And we'll do some examples of this on the next video.